Hello everyone. The title of this video is Find the Least Common Denominator, or LCD, of rational expressions, right, or fractions. So in this video, I'm going to go through 8 examples in which we're given two fractions, right, two rational expressions. And we're going to be asked to do two things. First, we're going to find what's called the least common denominator, or LCD, of those two fractions. And then second, we're going to rewrite each fraction as an equivalent fraction in which the new denominator is the LCD, right, that least common denominator. Alright, so before I get started, I just want to point out that every exercise I'm doing in this video is taken directly from a free online textbook at openstacks.org. It's their Intermediate Algebra 2nd edition. I am in section 7.2, titled Add and Subtract Rational Expressions, and I'm working on the exercises under the heading Find the Least Common Denominator of Rational Expressions. Alright, so I'm going to be working on exercises 99 through 106. Alright, so that's 8 examples. Example 1 in the video will correspond to number 99. Example 2 will be number 100, all the way down to example 8 being exercise 106. I have timestamps for each of the 8 examples in the description of this video. So if you'd like to take a look at a specific problem, say you wanted to look at exercise 104, that would be example 6. So just click on the timestamp for example 6 and you'll see me work on exercise 104, and so on. Pardon me. And I like to try to remember to say this each video. When you see me starting a new example in the video, pause the video and try to work on it yourself. Try to work through the problem and figure it out yourself. And then go back and see how I did it and compare your work with my work and see how well you're grasping the material. Alright, that's a lot better than just watching me do it and not doing anything yourself, because you're not going to learn anything that way. Alright, so into exercise 99. Like I said at the top of the video, there are 2 instructions for this. First, I'm asked to find the LCD, right, the least common denominator, for the given rational expressions. Right, so I'm given 2 fractions, 2 rational expressions, and asked to find the least common denominator. Then rewrite them, right? I'm going to rewrite each fraction as some equivalent fraction with the same denominator, so that I'm going to rewrite each fraction as an equivalent fraction so that each fraction has the denominator of the LCD. They both have the same denominator. Alright, so before I get into this example, we go into how you find the least common denominator, find the LCD. Right? How do you do that when you're given 2 fractions, 3 fractions, and so on? So first, you're going to factor. Right, and I'm going to assume that you know how to factor polynomials. If you do not, or if you're unfamiliar, a good way to refresh your memory would be to go through chapter 6 of that OpenStax Intermediate Algebra 2nd edition text. All the sections in chapter 6 have to do with factoring polynomials. So factor each denominator completely. Alright, just the denominators, not the numerators. All right, we're only focusing on finding the least common denominator, which is the least common multiple of the denominators, right? So I'm only going to be factoring each denominator completely at first. All right. Then the LCD will be equal to the product of each factor that appears, and this is going to sound funny, but hopefully you'll see what I mean after we get through several examples. The product of each factor that appears raised to the highest exponent, right, raised to the highest exponent on that factor. And again, this might not sound like it makes too much sense, but hopefully it will after I go through several examples. Okay? So, first example, the fractions I am given. We have 5 divided by x squared minus 2x minus 8, and 2x divided by x squared minus x minus 12. Alright, and first, again, I want to find the least common denominator, the LCD. So first I factor the denominators. So the denominators here, the denominator of the first fraction is x squared minus 2x minus 8. When I factor this completely, that would factor to x minus 4 times x plus 2. So when I say each factor that appears, the factors that are appearing here are x minus 4 and x plus 2. And if any factor appears more than once, you're going to write it with exponents, right? If I had the same factor twice, if I had x plus 2 times x plus 2 again, I would write x plus 2 to the second power, right? And if there was a third one, I'd write it to the third power, and so on. The other denominator, x squared minus x minus 12. This factors completely to x minus 4 multiplied by x plus 3. Right. And every single one of these is to the first power. We have x in the first denominator's factorization. We have x minus 4 to the first. Right, x minus 4 to the first, and x plus 2 to the first. In the second denominator's factorization, we have x minus 4 to the first, and x plus 3 to the first. So, I mean, you don't have to write the first power. I'm just doing it for this first example. So now I've done step 1 here, factor each denominator completely. Now we move on to the LCD. We can state what the least common denominator will be. So again, I'm going to read this out. It's the product of each factor that appears raised to the highest exponent on that factor. So what factors appear in the factorizations of the denominators? Well, x minus 4 appears times, there's an x plus 2 factor that appears, times, now x minus 4 I have already written, so I don't need to write it again. And then another factor I haven't written that appears in the factorizations of the denominators is x plus 3. So here's what I meant by the product of each factor that appears raised to the highest exponent on that factor. So you look at each factor. What's the highest? So look at x minus 4. What's the highest exponent on x minus 4 in any of these factorizations of the denominators? Well, in this factorization we have x minus 4 to the first, in this factorization we have x minus 4 to the first. The highest of those two powers on the x minus 4s is the first power. Again, you don't need to write it, but to the first power. And then I keep going down factor by factor. What's the highest exponent that appears above an x plus 2 factor? Well, there's x plus 2 to the first, and then this other factorization doesn't even have an x plus 2. So x plus 2 to the first is the highest power of x plus 2 that we see. And then x plus 3, the exponent on this will be the highest power on x plus 3 that we see in any of the factorizations of the denominators. I'm seeing x plus 3 to the 1, right? X plus 3 to the first in this factorization. And there's no x plus 3 up there, so the highest power on any of the x plus 3's is 1. So here it is. Here is the least common denominator, and I would recommend just leaving it factored. The least common multiple of the denominators, or the least common denominator for these two fractions, would be the product of x minus 4 and x plus 2 and x plus 3. X minus 4 times x plus 2 times x plus 3. Now, you could multiply it out, but I would recommend leaving it factored. We could multiply this out here, say the LCD. When I multiply x minus 4 and x plus 2, that would be x squared minus 2x minus 8, and then times x plus 3. And when I multiply these, we get, distributing the x, we'd have x cubed minus 2x squared minus 8x, and then I distribute the 3. We have plus 3x squared minus 6x, and then minus 24, and then combining like terms, I'd say the LCD was x cubed plus x squared minus 14x minus 24. Alright, this would also be valid. Alright, but I would recommend, and I'll write that as a note. I would recommend keeping the LCD in factored form. As you're going to see in this video and also in later videos on adding and subtracting fractions, that keeping the denominator in factored form is going to be very helpful and make simplifying the fraction at the end much easier. So I would recommend keeping the LCD in factored form. Alright, you don't have to. You don't have to. It's totally fine to multiply it out. But I'm going to keep things factored. Alright. So that was part 1. Alright, part 1 was find the least common denominator for these two fractions. And that's this polynomial here, x minus 4 times x plus 2 times x plus 3. Alright, next we are asked to rewrite each of these fractions as another fraction, an equal fraction, with this denominator. Alright. So let me do that here. So that's the second part. So I'm going to rewrite each fraction as an equivalent fraction with the same denominator, right? With the denominator of the LCD. With LCD, and I'll write the LCD again. The least common denominator was x minus 4 times x plus 2 times x plus 3. Alright, that's what I got earlier. Okay, so the first fraction, 5 over x squared minus 2x minus 8. Right, well, That's the same thing as the following, right? 5 over x minus 4 times x plus 2. Now to write an equivalent fraction, you need to multiply the numerator and denominator by the same thing, right? You can't just multiply the numerator by something and not the denominator, because that'll make an entirely different expression. But when you multiply the numerator and denominator by the same expression, it's like you're multiplying by 1. And multiplying by 1 doesn't change your values. Alright, so look at the LCD. X minus 4, x plus 2, x plus 3. Look at this denominator here for this fraction. It's got x minus 4, cool. It's got x plus 2, great. It's missing a factor of x plus 3. So that's what I'm going to multiply the denominator by. I multiply the denominator by x plus 3. So now the denominator is this LCD. But as I said a minute ago, right, you can't just multiply the denominator of a fraction by an expression. You must also multiply the numerator by that same expression. So I'm multiplying both the numerator and denominator by the quantity, this factor x plus 3. And as I said before, I would recommend keep the denominator in factored form. So my denominator is x minus 4 times x plus 2 times x plus 3 now, and multiply the numerator. Alright. So again, just to make things easier in the future, when we add and subtract fractions, I'll say this: keep denominator factored. Alright, but just the denominator for right now, right? Just the denominator at the moment. The numerator I'm going to actually multiply out, right? So 5 times x plus 3, that's 5x plus 15. And here we go. This is part 1. Okay, this is part 1. That's just the first fraction. All right. So this fraction has the same value as this fraction. And you can check that by replacing x with anything. Right? Obviously, you can't replace x with 4, -2, or -3, because that'll make you divide by 0. But anything else, if you replace x with any other number, this fraction that we started with will have the same value as this fraction. Right, so they are called equivalent fractions. They have the same value for every allowable value of x. And look at the denominator, right? The denominator is now the LCD, right? X minus 4 times x plus 2 times x plus 3. Okay, so I'm doing the same thing with the other fraction. Right, the other fraction is 2x for the numerator, and I'm just going to factor the denominator right now. Right, the denominator of this second fraction is x minus 4 times x plus 3. And then compare this to the LCD. We've got a factor of x minus 4, great. There's a factor of x plus 3, wonderful. The only things that are missing, the only factor missing, is this factor of x plus 2. So to make this into an equivalent fraction with the denominator of the LCD, I need to multiply the denominator by the factor x plus 2. And just as before, right, to make an equivalent fraction, you can't multiply the denominator by some expression and not the numerator. We have to do the numerator as well. That way it's like I'm multiplying by 1. So I multiply the numerator and denominator by this factor of x plus 2, and it gives me an equivalent fraction. Again, I'm going to keep the denominator factored, and if you want, any product of factors can be rewritten in any order you wish. So I'm going to write these three in the same order I did for the LCD here that I did there. So the denominator will have the factors, x minus 4 times x plus 2. There was a factor of x plus 2 that I just multiplied by. And then x plus 3. And I'll multiply out the numerator. Right? Take 2x here, multiply it by the x plus 2. That'd be 2x squared plus 4x. And there we go. Here's a fraction that has the same value as this fraction, right? This 2x over x squared minus x minus 12. This fraction and this fraction have the same value as long as x is not 4, negative 2, or 3, because if x is 4, negative 2, or 3, you're going to have a 0 in the denominator, and that's not good. But any other value, they'll be the same. Alright, and that was part 2. That's what we're asked to do. Rewrite each fraction we were starting with as an equivalent fraction with the same denominator, and that denominator is the LCD. Right. Now the whole reason we're doing this, right, rewriting fractions so they have the same denominator, is so that later we can add them or subtract them, right? Because remember, if you're going to add or subtract fractions, they must have the same denominator. That's the whole reason we're doing this. Okay, that was example 1. Example 2. Same instructions, right? Same instructions. So the first is to find the least common denominator, right? The LCD. Because right now the fractions have different denominators, right? This fraction has a denominator of y squared plus 12y plus 35. And this fraction has a different denominator, right? A denominator of y squared plus y minus 42. Alright, so remember, I wrote those steps up earlier, and I'll say them again here. To find the least common multiple of the denominators, or the least common denominator, the LCD, we take each denominator and factor completely. Now y squared plus 12y plus 35 factors to y plus 7 times y plus 5. And y squared plus y minus 42, that would factor to y plus 7 times y minus 6. Alright. So then now that each denominator is factored completely, I can very easily now state what the least common denominator is. So I'm just going to put all the factors that show up without repeating. So we have a y plus 7 times y plus 5 times, now again, y plus 7 I've already written. Alright, so I don't need to write that again. And then y minus 6 times y minus 6. And each of these has a power of 1. So the highest power of y plus 7 is y plus 7 to the first, so that's going to be to the first power in the LCD. Y plus 5, right, the highest power I see on y plus 5 is the first, so that's to the first. And the highest power on y minus 6 is also to the first. We'll eventually get to some examples where the power is not always 1. Okay, so again, I'll leave this in factored form. If you want, you can multiply it out and get the LCD, multiply it out. But I'll leave it in factored form. Okay, now, part 2, right, was rewrite. I'll just put rewrite. Right. I'm going to rewrite each fraction as an equivalent fraction with this denominator, right, with the LCD as the denominator. So the first fraction is 8 divided by, and y squared plus 12y plus 35, right, we've already factored this. This is y plus 7 times y plus 5. Right. There's the first fraction. Now, I would like it to have a denominator of the LCD. So I need to multiply the denominator and the numerator by some expression so that the denominator becomes the LCD. So I'm going to multiply this fraction by, by 1, but a clever one, right? Some expression where the numerator and denominator are the same. Look at the denominator. You have a factor of y plus 7, that's in the LCD. You have y plus 5, that's also in the LCD. So the only thing that's missing is this factor of y minus 6. So I multiply the denominator by y minus 6, and that'll give me a denominator of the LCD. And I also multiply the numerator by the quantity y minus 6. Make sure you put in parentheses around these. Alright, so when I multiply the numerator, we'll have, 8y minus 48. Alright, and I'll actually multiply the numerators. Alright. It's the denominator that I'm going to keep factored. Alright, so we have y plus 7 times y plus 5 times y minus 6. Alright, and there we go. There's part 1. Alright. This first fraction, 8 over y squared plus 12y plus 35, this is the same fraction as this one. And you can test it by replacing y with any number you want. The only values of y that can't be used are -7, -5, and +6. Right, because those would make my denominator 0, and you can't have that. Right, that's undefined. But for any other value of y, this fraction is equivalent to this fraction. And again, I leave it to you to test out some different values of y if you wish. Okay, second fraction, we have 3y over, and once again I'm going to factor the denominator. This denominator is y plus 7 times y minus 6. And I would like to change this to an equivalent fraction that has the same denominator as this first one here, right? The LCD as a denominator. Well, the denominator has a factor of y plus 7, like the LCD. Y minus 6, great. The only factor that's missing is y plus 5. So I'm going to multiply the denominator by the factor y plus 5 and also the numerator, right? You must do both. Right, so I multiply the numerator and denominator by y plus 5, and I'll actually multiply out the numerator and keep the denominator factored. Right? And again, there's a reason for this. The reason I'm multiplying the numerators out and keeping the denominators factored is because it'll actually make it easier when we go and add and subtract fractions in a later video. Right? But I want to get into the habit of doing this right now. So in the numerator we'd have 3y squared plus 15y. Now they may ask you in some exercises to leave the numerator factor as well, so you just leave it as 3 times y plus 5 and leave this as 8 times y minus 6, but I'm personally going to multiply out all the numerators. And then the denominator, again, you can write them in any order you wish if in a product, and I'll just write them in the same order that I did for the first fraction. So we have y plus 7, we have a factor of y plus 5, right, this one I multiply by here, and then times this factor of y minus 6. And here's a fraction that's equivalent to the second fraction. Right? So this 3y over y squared plus y minus 42, this fraction has the same value all the time as this fraction, as long as y is not replaced by -7, -5, or +6. Right? And again, test that out. Replace y with any number you want except these three, and the value of this fraction should be the same as the value of this fraction. And now we have what they asked for. Right? We have both fractions rewritten so that they have the same denominator. And once again, the reason we're doing this is so now, now I got these two fractions with the same denominator. Now I can add them or subtract them. Right? You can only add or subtract fractions when the denominators are the same, when they have common denominators. Right? This least common denominator is the nicest one. All right, next example. And I'm doing the same thing for all 8 of these. So once again, I'm given two fractions. I'm asked first to find the least common denominator. So the steps in that process again, look at each denominator. Right? The first denominator, that factors to z plus 4 times z minus 2. The other denominator, z squared minus 4, factors to z minus 2 times z plus 2. Right? And now that I have all the fractions denominators factored completely, we can very easily now state the LCD. Right, so the LCD is the product of, just list all the factors that show up and don't repeat anything. So we have z plus 4 is a factor, times, we have z minus 2 showing up as a factor. Again, don't write z minus 2 again, right? Don't repeat, and then times z plus 2. And then I look at each of them and I put the highest power I see up here in these factorizations on that factor itself. Now again, everything's to the first power, so all these will be to the first power. Right? We'll eventually get to an example where there's a higher power than 1. So there's the LCD, the least common multiple of the denominators, least common denominator. Z plus 4 times z minus 2 times z plus 2. And like I said in the previous two examples, I'm going to prefer to leave this in factored form. You could also multiply it out and write the LCD, and after you multiply it out, that'd be fine as well. Alright, now the second part is to rewrite the fractions that we were given so that we get an equivalent fraction with this LCD as the denominator. Alright, so the first fraction is 9 over z squared plus 2z minus 8. When you factor that, right, that's z plus 4 times z minus 2. So what I'm going to do, just like in the first two examples, I want to multiply this fraction by 1. I want to multiply it by an expression where the numerator and denominator are the same. And I want to do it so that the denominator becomes the LCD. Well, it's already got a factor of z plus 4. It's already got a factor of z minus 2. The only factor missing is z plus 2. So I need to multiply the denominator by the factor z plus 2. And the same thing for the numerator. Multiply the numerator by a factor of z plus 2. And don't forget to put parentheses around these. Alright, then when we multiply, now again, I'm just like in the first two examples. You can leave the numerator factored. You can write it as 9 times the quantity z plus 2. But I'm just for the future videos when we're adding and subtracting fractions, you're going to see it'll make it easier if we actually multiply out the numerators. So 9 times z is 9z plus 9 times 2 is 18. There's the numerator multiplied out. And I'm going to, as I did in the first two examples, leave the denominator in factored form. So the denominator is the LCD. It's got a factor of z plus 4 times a factor of z minus 2 times a factor of z plus 2. And there we go. That's the first fraction. So this first fraction, right, has the exact same value as this fraction no matter what you plug in for z. They are equivalent fractions as long as z is not -4, +2, or -2. Alright, because if you let z be -4, +2, or -2, you'll have a denominator of 0, and that's undefined. Dividing by 0 is bad. But for any other value of z, the value of this first fraction should be equivalent to the value of this fraction. Alright, so that was the first fraction. I'm doing the same thing with the second one. We have 4z over, and then z squared minus 4. Alright, that's z minus 2 times z plus 2. And just as with the first fraction, I would like to multiply the denominator and the numerator by the same expression so that the denominator is now going to be the LCD. Well, this denominator already has a factor of z minus 2, already has a factor of z plus 2. The only factor that's missing is z plus 4. So I multiply the denominator by the factor z plus 4, and I do the same to the numerator. Again, don't forget parentheses around this. You're multiplying by the entire factor, z plus 4. And if you want, you can leave the numerator factored, write it as 4 times z plus 4, totally fine. But like I said in the previous examples and the first part of this example, I'm going to actually multiply out the numerators and leave the denominator factored, and that'll make addition and subtraction of fractions easier later. I'm going to do that in a second, another video coming up. So the numerator is 4z squared plus 16z over, and then again, you have a product of factors. You can write these in any order you wish. So I'm just going to write them in the same order that I did for the LCD and for this denominator here. So we have z plus 4. There's a factor there, that one I multiplied by, and then times z minus 2 times z plus 2. And there we go. So this fraction I'm circling. This fraction I circled has the same exact value as the second fraction up here, the 4z over z squared minus 4, for any value of z, except for -4, 2, and -2, because those will make things undefined. But any other value of z, you can plug it in here, plug it in there, and they're going to give you the same exact value. Alright, and I'm doing the same thing every time. Example 4. Same stuff, right? Same instructions. First part of the instructions, find the least common denominator, right? Find the LCD. So again, I take each denominator and factor them completely. Right? A squared plus 14a plus 45. Now that factored would be a plus 9 times a plus 5. Right. The other denominator, a squared minus 81, factored completely, would be a minus 9 times a plus 9. Right, it's a difference of squares. Okay, so each denominator is factored completely. So now the LCD is just all the factors that appear, right, without repeating, to the highest power that you see that factor at. So I've got a plus 9 is a factor of the LCD, a plus 5 is a factor of the LCD, a minus 9 is a factor of the LCD, and that's it, because I already have a plus 9. And then once again, as in examples 1 through 3, every single one of these factors, a plus 9, a plus 5, a minus 9, the highest power you're seeing on any of these factors in the factorizations of the denominators is 1. Right? Everything's to the first power. So there's the least common denominator. Now, once again, you can leave it in factored form, or you can multiply it all out and write the LCD when you multiply it out and combine like terms like that, if you want. Second part of the instructions, right? We're going to rewrite each fraction as an equivalent fraction with this denominator, right? With the LCD as the denominator. So the first fraction, we have 6 over, and then I'm going to write the denominator factored. A squared plus 14a plus 45 is a plus 9 times a plus 5. And now what I wish to do is multiply the denominator and the numerator by some expression so that the denominator becomes the LCD. Well, it's already got a plus 9, it's already got a factor of a plus 5. The only factor it's missing is a minus 9. So I multiply the denominator by the quantity a minus 9, and I do the same for the numerator, the quantity a minus 9. Don't forget your parentheses. So again, you can leave everything factored if you wish when you write your final result. I am personally going to be multiplying the numerators out and leaving the denominators factored. So we have 6a minus 54 in the numerator, right? That's 6 times a minus 9. And then the LCD is the denominator, right? A plus 9 times a plus 5 times a minus 9. Right, there you go. This fraction that I just put a box around, this fraction is equivalent to the first fraction. That means that they have the same value no matter what you plug in for a, as long as you don't plug in negative 9, positive 9, or 5, or sorry, negative 5. Because if you plug in negative 9, positive 9, or negative 5 for a, you're going to have 0 in the denominator, and that's not good. That's undefined, dividing by 0. But for anything else, and I'm saying this every example, plug in any other value of a, and the value of this first fraction will be equivalent to the value of this second fraction that I wrote, this fraction I wrote here in the box. Alright, now I'm going to take the second fraction, the 5a divided by a squared minus 81, and do the same thing. Now a squared minus 81, that's a minus 9 times a plus 9. And once again, I'm going to write an equivalent fraction with the denominator of the LCD. So this denominator has a minus 9, it has a plus 9. The only factor this denominator is missing is a plus 5. Right, so I multiply the denominator by the quantity a plus 5, and I do the same with the numerator, multiply by the quantity a plus 5. And if you multiply the numerator out, now again you can leave things factored, but if I multiply the numerator out, that'd be 5a squared plus 25a divided by, and then again a product of factors can be rewritten in any order and still give you the same result. So I'm going to write them in the same order that I wrote for the LCD and this previous fraction. So the denominator has factors of a plus 9 times a plus 5 times a minus 9. Alright, and there you go. Alright. So this fraction is equivalent to this second fraction we were given at the start. So you can plug in any value of a you want, as long as it's not negative 9, positive 9, or negative 5, and the value of the first fraction will be the same as the value of this fraction here. And we have what we want. We have both fractions rewritten so that they have the same denominator. And once you have the same denominator for two fractions, you can then add them or subtract them, which is again what we'll get into in a future video. Alright, next example. So example 5, same instructions, and I'm going through the same procedure. So first let's find the LCD, right, the least common denominator. So I take each denominator, right? First denominator, b squared plus 6b plus 9. Alright, now remember, don't write the same factor twice. You're going to use powers. Right? This is b plus 3 times b plus 3 again. But you shouldn't write the same factor twice in the same factorization. So this is b plus 3 to the second power. So we finally have an example where one of the factors has a power higher than 1. Then the other denominator, right, b squared minus 2b minus 15, this would factor to b plus 5, nope, b minus 5, sorry, b minus 5 times b plus 3. Okay, so now that I have each denominator completely factored, the least common denominator is going to be made up of the following. You just list off the factors that show up. There's b plus 3's, so I write b plus 3, times, there's a factor of b minus 5, so there's going to be a factor of b minus 5 in the denominator, in the LCD. And those are it. Those are the only factors that show up in these factorizations of the denominators here. Alright, so here comes the part that we haven't seen yet. Alright, so far in examples 1 through 4, every factor had an exponent of 1. But now we have something different. So look at b plus 3. In the LCD, each factor gets an exponent that's the highest exponent of that factor in the factorizations of the denominators. So b plus 3, this first denominator has b plus 3 to the second. This denominator has b plus 3 to the first. Right? The highest of those is the second. So I have b plus 3 squared. Right? b plus 3 times b plus 3 in the LCD. Again, that's the highest power on b plus 3 that I'm seeing up here. And then b minus 5 to the first. Right? Again, there's only b minus 5 to the first showing up, but finally we get something in the LCD with a power higher than 1. Okay, so the least common denominator would be b plus 3 times b plus 3, right, or b plus 3 squared times b minus 5. Right. Okay, so now that I have the LCD, let's rewrite our fractions. So the first fraction, we have 4 divided by, and then the denominator, right, b squared plus 6b plus 9, that's b plus 3 squared. Right, b plus 3 times b plus 3. Alright, so just like any other example, I'm going to multiply the denominator and numerator of this fraction by the same expression so that the denominator becomes the LCD. Now notice it already has b plus 3 twice, which the LCD does too, b plus 3 squared. The only factor it's missing is b minus 5, so I need to multiply the denominator by the factor b minus 5 and do the same with the numerator. So again, you can leave this factored, write 4 times the quantity b minus 5 in the numerator, and then b plus 3 squared times b minus 5 in the denominator. That's fine. Nothing wrong with that. But I personally, just to make future videos easier to work with and make addition and subtraction easier, I'm going to actually multiply out the numerator and I'll leave the denominator factored. So the numerator be 4b minus 20, and the denominator is the LCD, b plus 3 to the second power times b minus 5. Okay, so here, this fraction that I just put in the box, 4b minus 20 over b plus 3 squared times b minus 5 like this, this fraction is equivalent to the first fraction, 4 over b squared plus 6b plus 9. They have the same value no matter what you plug in for b, right? As long as b is not replaced by negative 3 or positive 5. Because if b is replaced by negative 3 or positive 5, you'll be dividing by 0, and that's undefined. But any other value, right, replace b with 0, 1, 2, whatever you want, as long as it's not negative 3 or 5, this first fraction I'm pointing to will have exactly the same value as this fraction here that I'm pointing to now. All right. Second fraction, 2b in the numerator. And then the b squared minus 2b minus 15, that's, b minus 5 times b plus 3 in the denominator. And then just as before, I would like to multiply the numerator and denominator by some expression so that the denominator becomes the LCD, and I get two fractions with the same denominator, a common denominator, right? This least common denominator. Well, this denominator has a factor of b minus 5, so does the LCD. This has b plus 3 to the first power. The LCD has b plus 3 squared. That's two factors of b plus 3. This denominator only has one factor. So I'm missing a factor of b plus 3. So I need to multiply the denominator by b plus 3 and do the same to the numerator as well. I multiply by this factor of b plus 3. Don't forget parentheses. Once again, you can leave everything factored and write the numerator, write the denominator as a product. But as I've been doing in all the examples, I'm going to actually multiply out the numerator and keep the denominator factored. So the numerator would be 2b squared plus 6b, and the denominator is, b minus 5 times b plus 3 squared, but I can write it in the other order too, and so I'm going to write it just so I keep it the same as the earlier ones. So I have b plus 3 to the second power, right? There are two factors of b plus 3 times b minus 5. There's the denominator. All right. And this fraction I just wrote is exactly the same, has exactly the same value as the the second fraction we were given, the 2b over b squared minus 2b minus 15. All right, for any value of b except 3 and negative 3 and positive 5. All right. So if you replaced b with any number but these two, the value of this fraction would be exactly the same as the value of this fraction. And you can check that out if you want. Okay. Same instructions. Example 6. First, let's find the LCD. First denominator here, c squared minus 4c plus 4. That's c minus 2 times c minus 2 again. So c minus 2 to the second power. And then the other denominator, c squared minus 7c plus 10. This would factor to c minus 5 times c minus 2. All right. So the LCD is going to have a c minus 2 as a factor to some power, and a c minus 5 as a factor to some power, pardon me. And once again, look at each factor. What's the highest power you see on that factor in these factorizations of the denominators? C minus 2, the highest power on c minus 2 is 2. Right, there's c minus 2 to the second, there's c minus 2 to the first. The highest of these powers is 2. So we have c minus 2 to the second, and then what's the highest power on c minus 5s? Well, there's only c minus 5 to the first, so c minus 5 to the first that's the power that you're going to get in the LCD for c minus 5. Alright, so the least common denominator will be c minus 2 to the second, right? C minus 2 times c minus 2 times c minus 5. Now again, you can leave it in factored form or actually multiply it out and get a polynomial, right, written out, simplified for the LCD if you want. I'm going to leave it factored. Alright, then we're asked to rewrite. Right? Rewrite each fraction as an equivalent fraction with this denominator, right, with the LCD as a denominator. Right? The first fraction is 5 divided by c minus 2 squared. I need to multiply the denominator by c minus 5 to get that to be the same as the LCD. Right? It's already got c minus 2 squared. It's just missing the factor of c minus 5. And if I multiply the denominator by c minus 5, I also have to multiply the numerator by c minus 5. Don't forget parentheses. And you can leave it factored if you wish, but I'm going to multiply out the numerator. Okay, make the numerator 5c minus 25. And I'm going to leave the denominator factored. Right? The denominator is c minus 2 squared times c minus 5. Right? It's the LCD. Alright, so this fraction is equivalent to the first fraction, right, for any value of c except 2 and 5. So c can't be 2 or 5, right? Because if c were 2 or 5, you'd be dividing by 0, and that's bad. Alright, moving right along. The second fraction. We have 3c divided by c squared minus 7c plus 10. That's c minus 5 times c minus 2. And once again, I want to multiply the numerator and denominator by something so that the denominator becomes the least common denominator of these two fractions. Well, there's a factor of c minus 5 already. There's one factor of c minus 2, but the LCD has two factors of c minus 2, so it's missing one. So I need to multiply by another c minus 2 in the denominator. And if I multiply by c minus 2 in the denominator, right, I got to do it to the numerator as well. And once again, you can leave it factored if you wish, but I'm gonna multiply out the numerator. So 3c times this c minus 2. So the numerator after multiplying is 3c squared minus 6c over the LCD, which I'll write in the same order that I've been writing, c minus 2 times c minus 2, or c minus 2 squared, times c minus 5. And again, this fraction is the same as the second fraction we were given for any value of c except 2 and 5. Right? You can replace c with anything you want except 2 or 5, and the value of this fraction will be the same as the value of this fraction. And now these two fractions have the same denominator. And once two fractions have the same denominator, you can add them or subtract them. But we're not asked to do that just yet. Right? We're not asked to add these or subtract these. That'll be the next video. Alright, example 7. Same instructions. First, I find the least common denominator. So the first denominator, right, is 3d squared plus 14d minus 5. Factor that completely. And that would factor to 3d minus 1 times d plus 5. And you can check by foiling. Okay, and the other denominator, 3d squared minus 19d plus 6. This would factor to 3d. I need a minus 6 over here and a minus 1 there, right? That'll be minus 18 minus 1 for minus 19 and plus 6. Good. 3d minus 1 times d minus 6. So the LCD, right, now we're back to those examples where everything was to the first power. The LCD is going to have factors of 3d minus 1, d plus 5, and again, don't write 3d minus 1 again. I already wrote it. And then d minus 6 to some power. And the highest power on any of these is the first power. So there's the LCD, right? All those factors to the first power. 3d minus 1 times d plus 5 times d minus 6. Now if you'd like, again, leave it in factored form. That's what I'm going to do. Or you can actually multiply this out and write the LCD as a fully fledged, fully formed polynomial. Next, we'll rewrite the fractions as equivalent fractions with this denominator. So the first fraction, you have 2 over, and we already factored the denominator here. I'm going to do that again. We got 3d minus 1 times d plus 5. And now I just want to multiply the denominator and the numerator by the same expression so that the denominator becomes the LCD. Well, it's got a factor of 3d minus 1. It's got a factor of d plus 5. The only factor it's missing is d minus 6. So I multiply the denominator and the numerator by the quantity d minus 6. And when you multiply, you can write the products, the numerator as a product, denominator as a product. You can leave them factored if you want, but again, you've seen me in examples 1 through 6. Multiply the numerators and, leave the denominator factored. So I got 2d minus 12 in the numerator, and the denominator is the LCD, 3d minus 1 times d plus 5 times d minus 6. There you go. All right, so this fraction is equivalent to the first fraction we were given. They have the same value no matter what you plug in for d, as long as d is not 1/3, -5, or positive 6. Alright, d can't be 1/3, -5, or positive 6, because if it is, you'll be dividing by 0, which is not defined. That's bad. But for any other value of d, you plug it in here to this expression, you plug it into this expression, you're going to get the same value back. Okay. Second fraction, same thing. I got 5d in the numerator, and the denominator, when factored, is 3d minus 1 times d minus 6. Now, in order to change this fraction into an equivalent fraction with this LCD as the denominator, I need to multiply the denominator by d plus 5. Alright, that's the only factor that's missing. And if I multiply the denominator by d plus 5, I must also multiply the numerator by d plus 5. And once again, you can leave this all factored like this, or multiply the numerators out like I've been doing. You have 5d squared plus 25d in the numerator, right, after distributing. And the denominator, again, I'm going to write this product in the same order I've been writing the other factor, right? Write the LCD, so that way it's obvious that they have the same denominator, 3d minus 1 times d plus 5, right, and then times d minus 6. And there you go. All right. And this fraction is equivalent to the second fraction we were given. All right. They're the same value no matter what you plug in for d, as long as you don't plug in 1/3, -5, or positive 6. Right. But for any other value of d, these are the same fraction. These are the same value. And finally, same instructions. Right, example 8. Same instructions. Find the LCD. So first denominator, 5m squared minus 3m minus 2. I factor this. This would factor 2. You have 5m and m. Then I would need so I'd need a minus 1 over here and a plus 2 here. Right? That'll give me minus 5 plus 2 would make minus 3. So that factors to 5m plus 2 times m minus 1. The other denominator, 5m squared plus 17m plus 6. This would factor, you'd have a 5m in one of them, m in the other. Then I need plus 3 over here, plus 2 here. All right. Gives me the 15m and the 2m for the 17m. 5m plus 2 times m plus 3. Alright, so the LCD, right, the least common denominator, again, you just list all the factors that show up once. So there's a 5m plus 2 to some power. There's going to be an m minus 1 to some power. And 5m plus 2 I already wrote, and then m plus 3 to some power as factors of the LCD. And the highest power of each of these is the first power, right? You're not seeing any higher powers than 1, so that's it, right? So the LCD is 5m plus 2 times m minus 1 times m plus 3. And like I've been doing, I'm going to leave this in factored form, right? Or you can actually multiply it out and write the LCD as a fully formed polynomial. Alright, then we're going to rewrite each fraction as an equivalent fraction with the LCD as a denominator. The first fraction, I have 3 over 5m plus 2 times m minus 1. Right? This is 5m squared minus 3m minus 2. I want to write an equivalent fraction with the denominator changed to the LCD. So I need to multiply the denominator by m plus 3, right, the quantity m plus 3. That'll give me all the same factors as the LCD. And if I multiply the denominator by the quantity m plus 3, I must also multiply the numerator by the quantity m plus 3. Now you can leave it all factored like this, write the numerator as a product, the denominator as a product. But like I've been doing in every example, I like multiplying the numerator out, leaving the denominator factored. So we have 3m plus 9 for the numerator, and the denominator is the LCD 5m plus 2 times m minus 1 times m plus 3. Right, and there you go. Alright, so the value of this first fraction, right, is equivalent to the value of this fraction for any value of m, any choice of m, except what makes the denominator 0. So m can't be negative 2/5, positive 1, or negative 3. Right. M can't be negative 2/5, positive 1, or negative 3, but it can be any other value. Right? And if I replace m with any other value, the value of this first fraction will be exactly the same as the value of this fraction I have in the box here. All right, and finally, the second fraction, I got 6m in the numerator, 5m squared plus 17m plus 6. I'll write that in factored form as 5m plus 2 times m plus 3 in the denominator. And to get an equivalent fraction, with the denominator being the LCD, right, I need to do the following. The 5m plus 2 is there, the m plus 3 is down there. The only factor it's missing is m minus 1. So I need to multiply the denominator by m minus 1 and also the numerator by the quantity m minus 1. And once again, you can leave everything in factored form like this, but I have been multiplying the numerators out. So that'd be 6m squared minus 6m in the numerator, and the denominator is now the LCD. And I'll write these factors in the same order I've been writing them. So you have a factor of 5m plus 2 times a factor of m minus 1 times a factor of m plus 3. And there's the second fraction written as a fraction that's equivalent to it. Right? They have the same value for any choice of m except negative 2/5, 1, or negative 3, but for everything else they're the same. Wonderful. Right, so that's a lot of stuff there, right? But you're going to be doing this again. All right. This is kind of a build-up to adding and subtracting fractions. All right. In order to add or subtract fractions, you need to make the denominators of those fractions the same, which we have done, right? In examples 1 through 8 here, we've taken two fractions with different denominators and rewritten them as two fractions with the same denominator. And then once you do that, then you can add and subtract the fractions and then simplify. All right, so that's going to be in the next video, which I'll be making shortly after this, I'm sure, or maybe tomorrow. It doesn't matter what day you're watching this. You don't know what day this is. Yeah, so hopefully watching me go through these 8 examples help you out, when you're working on similar ones. And thank you very much for watching.